Let's start with electric charge. There are two types of charge, positive charge and negative charge. And when there are charged particles brought close to each other, then it will produce electrostatic force. Okay, charged particles, when we put them close together, then electrostatic force will be produced. Okay, and then if the two particles carry same charge or like charge, like charge or same charge. Okay, like charge means same charge. They will repel. Okay, be it the positive or negative. Okay, if the charge is the same, then they will repel. Unlike charges means different charges. Okay, positive and negative. They will attract. Okay, they will attract. Then how about a charged particle with a neutral object like this one? Okay, this is charged, but this is neutral. Neutral because you see the number of positive and the number of negative are the same, right? Okay, so this is neutral. This is neutral object. If you put a charged object close to a neutral object, the charged object will pull or attract the neutral object. Why? Because when this charged object is brought close to the neutral objects, then if this is negative, it will push the negative charge in the neutral object. It will push it to another side. Okay, and cause this object partially charged. Overall, it's still neutral, okay, but this side is positive and this side become negative. Okay, and this is negative, right? So negative will attract positive. So a charged particle can attract a neutral object. If this is positive, then it will pull the negative charge closer to the left hand side, okay, and then it will pull this object. Okay, so a neutral object is attracted by both positive charge and negative charge. Okay, so like charge repel, unlike charge attract. A charge with a neutral object, a charged object with a neutral object, they will attract. Okay, they will attract. That's the first thing that you need to know. The unit of charge. The SI unit of charge is given by Coulomb. Coulomb. One Coulomb is equal to 1 ampere second. So ampere second, both ampere second and Coulomb are the unit of charge. They are the same. Ampere second and Coulomb are the same. Okay, because sometimes in the test or exam, okay, they will give you both Coulomb and ampere second, and then they ask you which one is correct. Both are correct. Okay. Okay, so that is the SI unit of electric charge. Coulomb. The unit is Coulomb. Charge of one electron. Okay, charge of one electron is equal to negative 1.6 times 10 to the power of negative 19 Coulomb. And charge of one proton is positive 1.6 times 10 to the power of negative 19 Coulomb. From here, you can see that the charge of one electron and proton is very, very small. Very, very small, okay? But their values are the same. 1.6, 1.6. Their values are the same, but one with negative charge, one with positive charge. So that's charge of one electron or proton. Now, you don't need to memorize this. Okay, you don't need to memorize this because in exam, if you need these values, this will be given. Will be given in the questions. Okay. Charge and relative charge. Now, in chemistry, you have learned that the charge of electron is negative 1 and the charge of proton is positive 1. Okay. But now in physics, we learned that the charge of electron is negative 1.6 times 10 to the power of negative 19 Coulomb. Okay, so why in chemistry we say the charge is negative 1, but in physics we say it's negative 1.6 times 10 to the power of negative 19. Okay, that is because in chemistry, this negative 1, positive 1, aluminium ion, positive 3, oxygen ion, negative 2, these are called the relative charge. Okay, the relative charge. It's not the actual charge. It's the relative charge. Okay, relative charge is the charge where they compare with each other. Okay, yeah, relative means compare in comparisons with, compare to each other. Okay, but physics we are more interested in the real charge or the absolute charge. Okay. But just let you know, okay, so that's the difference between the relative charge and the absolute charge. So for proton, the charge is positive 1.6, but if aluminium, the charge is positive 3, okay, then the actual charge or the real charge of aluminium will be 3 times the charge of a proton, right? This is positive 1, this is positive 3, so it's 3 times the charge of the protons. Okay, sum of charge. We can find the sum of charge by using this formula. Sum of charge equal to the number of charged particles times charge of one particles, or the formula Q equal to Ne. Q equal to Ne. For examples, let's say the charge of electron. The charge of electron is given by E. E equal to negative 1.6 times 10 to the power of negative 19 Coulomb, right? If we have 200 electrons, okay, 200 electrons, then the charge Q is a symbol for charge. Q equal to the number of electrons, 200, multiplied by the charge of one electron, 1.6 times 10 to the power of negative 19 Coulomb. So what's the answer? Now just now we learned that the charge of one proton, the value is the same, okay, it's 1.6, but it's positive, positive 1.6 times 10 to the power of negative 19 Coulomb, okay. And let's say we have 2,195 protons. What's the charge of this number of protons? So the sum of the charge, Q equal to the number of protons, 2,195 multiplied by positive 1.6 times 10 to the power of negative 19 Coulomb. And this is equal to 3.512 times 10 to the power of negative 16 Coulomb. So that is how we find the sum of the charge. The sum of the charge for electrons or protons. This number of charged particles can be electrons or protons. Usually it's electrons or protons, but sometimes it can be ions. But in physics, normally they will ask you to find the charge of electrons or proton. And this E is a charge of one charge. The charge of one charged particles, okay, and usually it's electrons or protons. Electron is negative 1.6 times 10 to the power of negative 19, and a proton is positive 1.6 times 10 to the power of negative 19. You don't need to memorize this number or this value because it will be given in exam. Example 1. Okay, this one I want you to try. The answer is negative 4 Coulomb. How many protons are there in positive 2.5 coulombs of charge? Charge of one proton is positive 1.6 times 10 to the power of negative 19 Coulomb. Okay. So this is the answer. 1.5625 times 10 to the power of 19. Okay.